So physical and chemical changes. And here you're being asked to recognize if a chemical and physical change will happen. And it's stating it does happen all around us, and can you recognize it? So um, if you can change the way something looks by having made a new substance, we call that a physical change, and usually it happens in the particle level. And if the substance has been changed into something that is another substance, meaning has different chemical and physical properties, usually we call that a chemical change. So, number one, when an ice cube is placed in the sun, later there's a pot of water, later it's gone. Uh, Ice cube here is melting into water, and then it's evaporating or going to a gas state slash phase change. That is most likely to be a um, just a physical change. When I say most likely, is you can be almost sure that it is a physical change, but in science, you can never really be sure about anything. You cannot prove anything in science. You can only disprove things. So, two chemical are mixed together and a gas is produced. So we're mixing things up, and again, going back to our table, and we see that if we got gas being formed when we're mixing things up, that is a good chance that it's going to be a chemical change. A bicycle changes color as it rusts. When things are rusting or tarnishing, that is usually a sign of a chemical change. A solid is crushed to a powder. All we're doing here is we're changing the size of the particles and perhaps even the shape. So that is only going to be physical change. And when you got two substances being mixed and light is being produced, that is most likely going to be a chemical change. And usually, when you get light, you get heat also. That is one of the most obvious evidences or signs of a chemical change. When you got a piece of ice melting and then reacting with sodium, now here you got both. Melting, we know that's just a state change. So that is just physical, but then reacting, that means we probably got light, heat, explosion going on. So that is the chemical part. So both for number six. Mixing salt and pepper. Usually when it just says mixing, that is going to be a physical change. We can then really separate them later. So that's just a physical change. Chocolate syrup is being dissolved. Again, dissolving is just molecules hiding behind other molecules. If you really wanted to, you can separate them. So that's a physical change. Marshmallow, when it's toasted, it tastes different. It smells different. It looks different. So that is a chemical change. If a marshmallow is cut in half, well, that's just a physical change because it's just changing its size slash shape, but it's still marshmallow. It doesn't taste different, doesn't smell different. Just the way that the particles are being bunched up um, in a in the bulk scale now looks different, but still marshmallow. So on part B, you have a scenario, and you have to decide if it's going to be a physical or chemical change, and sometimes it could even be both, and then provide in evidence. So when a student removes a loaf of bread, um, hot from the oven, the student cuts a slice of the loaf and spreads the butter on it. So that's physical because you're cutting and you're spreading the butter, but you are not really changing the substances into something different. You say, well, it will taste different. That's because you got butter now mixed up with the bread. And there's no change in substance, no expected color change, temperature change, or gas given off. And if you look again in this list, you would be able to tell if the change is chemical or physical. And when your friend decides to toast a piece of bread, he leaves it in the toaster too long. The bread is black and the kitchen's full of smoke. Well, I got here black that really did not come due to color being mixed, but burning. And I got smelling. It's going to smell different because of gas being formed. And so that really looks like you can even if you dig deeper, you might be able to find other signs. But that looks to me like it's a chemical change, and the evidence we just discussed. If you forgot to dry the bread knife when you washed it, and the reddish brown spot, usually reddish brown spot indicates rusting, and when things rust, really they're the metal is reacting with oxygen and it's making something that's completely different. So that would be your evidence for chemical change. You blow dry your hair wet. You're just removing the water. So that's just a physical change. Um, Water is going from liquid in your hair to now being a gas. So that's the state change that water is going through. When you're baking a biscuit and baking powder reacts, again, the word react here tells me something chemical is happening to release carbon dioxide bubbles. So I got bubbles forming or being released, gas, and it's causing the dough to rise. So that is a chemical change. If you need to really more evidence in there, focus again on this list, and you should be able to pick up a couple. You take out your best silver spoon and notice that they have a very dull and some black spots. That is probably what we call tarnishing. So that is chemical change. So we got reaction with oxygen going there. A straight piece of wire is coiled to form a spring. Well, the wire it's still the same wire. It's just looking like a spring now. So that's just a shape change, or physical form change. So that's a physical change. Food color is dropped into water to give it um, color. That's just color mixing. Really, you can still separate the food coloring from the water, so that's just a physical change. When you chew food to break it down in smaller particles, well, you're just changing its size, so that's a physical change. But the changing of the starch into sugars, you're changing starch into sugar, so you're changing one molecule, one substance into something else by the enzymes in the digestive system. That is a chemical change. We're changing starch into sugar. So one substance is being completely changed to something else with different properties, physical and chemical. So that is chemical change. In a fireworks show, the firework explode, giving off heat and light. Again, explosion. When you got heat and light being given off, that is a tremendous sign of a chemical change. And true or false, changing the size and shape of piece of wood would be a chemical change. That would be false, because when size and shape is being changed, usually that is physical. In a physical change, the makeup of matter is changed. Um, Not really the makeup, but just the organization, how particles are being spaced, how they're being organized, changed, but not what they're made out of. We're not changing how the particles are what particles are making up the substance. So that would be false. Evaporation occurs when liquid water changes um, into a gas. So that is a physical change, and that is true. When water goes from liquid to gas, we know that's evaporation. That's a state change. Evaporation is a physical change. Yes. Burning wood is a physical change. No, that is false. So this is true. True. This is false. Um, in combining hydrogen and oxygen to make water is a physical change. That is false. If you're combining things to make completely something different, that is a chemical change. So that is false. Breaking up concrete is a physical change. That is true. We're just breaking it up, a chunk of concrete, into smaller pieces. Sand being washed out to the sea from the beach is a chemical change. That is not true. We're not changing the sand. We're just changing where it was before. When ice cream melts, a chemical change occurs. That is false. Again, we got the keyword here, melting, which you know is a state slash phase change, which is a physical change. Acid rain damaging a marble is a physical change. That's false. When acids react with marbles, you'll see some bubbling. That is a chemical change.